All right. Dear Heavenly Father, we thank you for this day again. I thank you for these students. Just ask that you'd bless our work today. Help us to glorify you in what we do, and just understand a little bit about your creation, about math today, Lord. In your name I pray, Lord Jesus. Amen. Okay, so let me get straight into it here, unless there's a question about something. No questions? So we now have methods for completing the square, right? And so we can do things like solve applied problems, right? So let's look at one. All right. So today we're covering a token application of the quadratic formula / equation, maybe an example or two. And then we'll talk mostly about how to graph a quadratic equation, right? And the graph of a quadratic equation is a parabola. So to describe a parabola, we'll see we need to understand x-intercept, y-intercept, but most importantly the vertex. So that's where we're going, all right? But for now, an example. So example 1. Yeah. All right. Example 1. Suppose you have a 400 square foot dog pen whose width is twice its length, and 2 more feet. Sorry, my grammar is not optimal. You get the idea. So the length is twice the width, and then 2 more feet past that. All right. There's a better way to write this sentence, but I am sick, so sorry. And the bad news is, I'm teaching that 8:15 class this semester, so I'll probably stay sick. So get used to this.
Everybody's getting sick.
Yeah.
Oh, what it is.
It's almost like we've got people crammed into rooms with not enough space. But anyway, not here, of course. Okay, so the first thing you do with a problem like this is you draw a picture, like so. And you label one of these guys length, and you label the other one width. It doesn't really matter which is which, right? And what do we know? Oh, we know that the area is the length times the width, and we also know that that's equal to 400. Now, you could write 400 square feet, but we're just going to write 400. We're going to work in feet. All right? Like, for a very similar example, this is almost the same as your recommended homework problem number 47 from section 1.5. But that one's in yards. And it's got the very scary 40,000 square yard. But I thought this would be more fun for you guys. Anyway, if you want to watch me work that one, you can watch the earlier lecture section. Now, what equation do we have here? The width is twice the length and 2 more feet. So what I mean by that is 2 times L, right? 2 times the length plus 2. Right? Like if there's a better way to write that sentence, like it's 2 more feet than twice its length would be a more natural way to write it, right? Wonderful. Okay, so then what do we do? How do we solve this? Why am I even talking about this in this class? Like, what have we been solving? We've been solving quadratic equations. How is this a quadratic equation? Any ideas? What should we should just do what? Take this, right? Plug it up in there. And then we've got length times twice the length plus 2 is equal to 400. Now, I know who you guys are. So, in the interest of everyone tracking me 1,000% better, let us change L to x. X times 2x plus 2 equals to 400. So let's just change the letter to x so that the algebra is like, you know, easier to think about. And then what do we got? Yeah, we got 2x squared plus 2x minus 400 equals to 0. That's a quadratic equation, right? We can solve that. But, yeah, factor out the 2. I'm going to take your factor out of 2, and I'm going to raise you a divides by 2. And the reason for that is that now we're dealing with equations, right? So all that blathering I did last time about factoring was for expressions. Well, we're in an equation now. We can divide, make the 2. So divide by 2. X squared plus x minus 200 equals to 0. Hooray. Now how do we solve this? You're like you being you, you're going to complete the square, right? I'll tell you what, I will use the quadratic formula. Would that make you feel better? No? Don't make me cough. All right, so quadratic formula. X equals to minus b plus or minus the square root b squared minus 4ac, all divided by 2a. You are allowed a sheet of notes on test 1. I would encourage you for this to find its way into your sheet, right? All right, so what's a? A is 1, b is 1, c is minus 200. So this formula in this context is minus 1 plus or minus the square root of 1, 4 times 800, so 1 plus 800, all divided by a 2. So we get minus 1 plus the square root of 801 over 2, or minus 1 minus the square root of 801 over 2. Which one of these should we bother to actually find a decimal form of? And which one should we be like, nah, no thank you, I don't want that one? Which one can we ignore? The first one probably. It was 50-50, but sadly, well, which is the first one? Is it the one closest to you?
Oh, 1 second. No, I see what you're talking about.
Right, this one's negative, right? So can the length be negative?
No.
Nah. So this has got to be the answer. So we calculate the square root. Let me get on. Got to get my mode. Just here, my mode. So here, plus. Oh, well, not plus. Minus. Minus 1. Divide by a 2. And then decimal. I get a decimal of approximately, come on, marker. 13.65-ish. So if that's the case, what's the width? Twice 13.65, right? Plus 2, so the width is 29.30-ish. So I never actually finished this question. Usually Usually the end of this question is state the dimensions for the dog pen, right? So now that we've done all this work, can we state the dimensions? What are dimensions? Right, the sides. So the answer is? Okay. Yeah, 29.30 feet by 13.65 feet. And of course, you know, I have just arbitrarily chosen to approximate to the hundredths place. Your actual problem in the book might be like approximate to the 10th place or whatever. I'm not super critical about that. This isn't a chemistry class. Like, it's not my goal to teach you sig figs in here, right?
Sig figs are so dumb.
Sig figs are dumb, yes. Preach it. If we're right, what should happen when we multiply these numbers as a quick check? What's 29.3 times 13.65?
Good question.
I get 399.97. I'm pretty happy with that because I was only keeping up to the hundredths place, so my answer is only up to the hundredths place. That's usually how it goes. Any questions? So pretty much all of the recommended homework that I've given you guys, applied-wise, they're all like geometric. It's like a picture, look at one length, look at another, and you, from looking at the picture and the problem statement, you come up with an equation. It's a quadratic equation. You solve it. That's pretty much the nature of the beast for all of them. All right. We can do another one of those another day if you guys have questions, okay? But I'm going to go on to talk about the graph of, I want to talk about graphing.
Do you want to move the camera?
I will. Graphing, thank you for reminding me, y equals ax squared plus bx plus c. Oh, you got me? Thank you. So this is a what? It's a quadratic. Yeah, it's a quadratic equation. But what geometrically do we call the solution? Yeah, it's a parabola. What is a parabola, though? I see some of these, right? It's like one of these. But what is it? Can you tell me geometrically what a parabola is? It's a what? It's bended. I mean, this is also true. How about this? Like a circle is the set of points that are the same distance from a central point, right? It's a set of points equidistant from a central point. What's a parabola in that kind of thinking? Anybody know?
Oval that doesn't close.
An oval that doesn't close. That's not entirely wrong. I mean, ovals and parabolas are a part of the same discussion, honestly. They're both examples of conic sections. But anyway, no, what we should say is that it's a collection of points which are the same distance from a line which is called the directrix and a point which is called the focal point. So there's a focus and there's a directrix. The parabola is the collection of all points which are equal distance between that line and that point. Now, don't worry, I'm not even going to ask you to find the equation of the point or the line. I just want you to know it's there, all right? Like, that's how we define a parabola geometrically. But it seems like nobody's teaching that in high school anymore, which is kind of sad, because they should, even cheated. Anyway, so graphing this, there's just a few things that I want to make sure you know about. First of all, if y is equal to a times x minus r1 times x minus r2, then, well, r1 comma 0 and r2 comma 0 are x-intercepts of the graph. In other words, that's where the graph crosses the x-axis, right? Of course, I'm assuming that r1 and r2 are real numbers, right? Can you guys tell me what's the y-intercept before I do anything else? What's the y-intercept for this parabola? A? How do we find y-intercept? That's when x is equal to 0, right? So you get 0, comma 0 plus 0, c, y equals c. So 0c is the y-intercept for this thing. That's easy. Well, it's usually easy. It can actually require work to find that. Number 2, and this is easier still, just something to keep in mind. A greater than 0 opens up. A less than 0 opens down. All right. That's point number 2. Point number 3, and this is a little bit fussier, but if y is equal to a times x minus h quantity squared plus k, then h comma k is the vertex of the parabola. So if you have that form, that's called vertex form of the parabola because, well, you can read the vertex right off that form. Now, past this, I like to derive some formulas that relate these things together. So give me a few minutes of derivation time here. Follow me here. So if I take a times x minus r1 times x minus r2 and I multiply it out, what happens? Like FOIL this out, what you got? You got ax squared, right? And then minus a times r1 plus r2 x plus a r1 r2. Now, you might need to do a step before you get to there, but if you look at what you did, multiply it out, group the things, you should get that. However, what else do we know? Well, y is also equal to, come on, markers. Y is also equal to ax squared plus bx plus c. So you can, now you've worried me.
It looked good.
Oh man. Yeah, I need to zoom out a bit. Thank you. My bad. Equating coefficients. Two polynomials are only equal if they have the same x squared coefficient, the same x coefficient, the same constant coefficient, right? This is a principle we can always use. So like, when I compare these two, I compare the coefficient of x squared. A equals to a. So a equals a. No one cares, right? How about this one, though? This equals to that. What's that tell me? That tells me minus a times the sum of the roots is equal to b. Or in other words, the sum of the roots, r1 plus r2, is equal to minus b over a. Hooray! That's a nice formula. And also, if you look at this is equal to that, we get that a times the product of the roots is equal to c. So the product of the roots apparently has to be equal to c over a. That's kind of a nice formula to know about. It has its uses. But what you'd really like me to find for you is a formula for the vertex. All right? So let's multiply this out. What happens when we FOIL out the vertex here? This is equal to what? This is equal to a times, multiply x minus h squared out, you get x squared minus 2xh plus h squared plus k, right? All I did was just multiply that out, multiply it out. Now let's put things together, let's collect things. So what we're looking at here is ax squared. What's my coefficients for x? Well, I've got minus 2ahx plus h squared plus k. Again, that has to be equal to ax squared plus bx plus c, right? That still has to be equal to ax squared plus bx plus c, right? So what's that tell me? That tells me formulas. It tells me, one thing it tells me is that a equals a, who cares? The other thing it tells me, though, is that minus 2ah is equal to b. Oh! That's actually very nice. That gives me a straight up formula for the vertex, the h coordinate for the vertex. Here it is. H is equal to minus b over 2a. And what is that actually also equal to? Look at the other formula we have here. Yeah, that's what? 1/2 of minus b over a, which, like you just told me, that's 1/2 of r1 plus r2. What's that mean? The vertex is the x value of it. It's at minus b over 2a. But by the way, that's also halfway. It's the average of the roots. So if you got one root at 10 and you've got another root at 8, then the average of 8 and 10 is 9. So that means the vertex is going to be at 9. It's right smack dab between the roots. That's where the vertex is. And we just derived that. Now the formula for the k part of the vertex, not as exciting, but here it is. I almost never use this, but let me get it for you. So we've got ah squared plus k equals to c. If I solve that for k, I get k as c minus ah squared, which is c minus a times minus b over 2a squared. I'll get out of the way here. So if I clean that up, the formula that I find is k equals to c minus b squared over 4a. So, you know, these are plug and chug formulas to find the coordinates of the vertex if you want to use them. In practice, I don't tend to find the vertex with these formulas, but it's nice to know about them in the pinch in case we need them. So how do you think we're actually going to find the vertex for an example? What's usually the answer to any question I pose like that in here? I look at the graph. We're trying to make the graph. We can't look at it. Our job is to construct the graph. We're not given it. Okay, admittedly, there are problems in the book where you're given the graph and you're supposed to read things from the graph. That's another thing altogether. We can do that also. Maybe I should show you some examples, all right? So this is just the general story. Let us look at some examples. You know, this room is really annoying. Why is there a chair and a table? Like, is this a classroom? Like, do people actually teach here? I don't know. Sorry, I get annoyed at times. Okay, so example 1. Where was I? Here we go. Let's try to graph. We'll keep it real simple. Y is equal to x squared minus 7x plus 6. Can we graph this thing? How should we graph it? What do you guys think? Low hanging fruit. What's the y-intercept for this dude? The y-intercept is 6, right? To be more explicit, the y-intercept is the point what? 0, 6, right? Now, and then what? Can you factor this? What did you say? Minus 1 plus 7. Minus 6 minus 1. How many vote for 6 and 1? How many 6 and minus 1? How many vote for minus 1 and 6? Yeah, I think it's got to be minus 1 and minus 6, right? Because we got that minus 7, so we need to get minus 1 plus minus 6. So hooray, factoring. It's still a thing, right? We don't always have to complete the square. By golly, I don't want to complete the square in this, because if I was to, I would be up against the dreaded 7/2. And then I'd have to subtract 49 quarters, and it would just have been unpleasant. So what's the x-intercepts? From this one, 1, 0. From that one, 6, 0, right? Where's the vertex? Where's the vertex? See, if we know the x-intercepts and the y-intercept and the vertex, then we can make a really good graph, right? So how would you figure out the vertex? Where is it at? So my usual notation is h, right, is equal to, what do we got? 1 plus 6 over 2. Apparently the vertex is at 7/2. Oh my goodness. All right, I'll try to end class early, guys. You shouldn't have to be in here with me that much longer. See if I can wrap this up here. I'm going to try to do 3 examples.
Wait, how is it negative 1 and negative 6?
Because add those two negative 7.
Fact, it's just, okay. So that's where the vertex is in the x sense. Where is it in the y sense? How do you figure out where it goes? What's k? The way to get k is you plug 7/2 back into the formula. Which formula should you plug it into? I think the easier formula to use here is this one. The red formula is nicer. You know? I don't know, like you can, whatever. It's 6 and 1/2 dozen the other. 7/2, something my grandma used to say. That saying is lost. 7/2 minus 6, which is like a fraction. So we're up against 5/2 times minus 5/2, I think. Is that right? 7 minus 12 is minus, yeah. So I get minus 25 over 4, which in decimals is what, like minus 6.25? And this is 3.5. So my vertex is at apparently 3.5 comma minus 6.25. Making use of all our handy dandy formulas we just derived, right? Fractions are also okay. I'm putting it in decimal because I'm going to make the graph, and like for me, graphing just I can see things better. So the intercepts are on 0, and 0. The water is 0. A 3.5 and 0.5 here. Estimates are 3. So this is the graph approximately. That's what the intercepts are, right? The vertex should be worse. Find this one. Find this to work. I never could write already all that. I just have back. Okay, that would look a little bit, but that's not more. But sure. it's